All right. So what we're going to be talking about today, this is an advanced Bicep language lab. So we're just going to be going over a few features in depth that we consider kind of like advanced Bicep usage. We'll start off a little slow and then get faster. Feel free to interrupt at any time if you have questions, but I will leave time for questions at the end. The chat is open. And yeah, yes, thank you to the sponsors of PSConf EU. You can see them listed on this slide. Okay, so who am I? My name is Jonny Eskew. I'm a software engineer on the Azure Deployments team. I primarily work on Bicep on what I would call like quality of life and safety features. So these are things like type declarations and checking, um, validations, things that let you shift left validation on your template so that you can get some form of confidence that it's going to work the way you want it to before you actually hit the deploy key. I also work a lot on the ARM template expressions language and a feature called What If that you'll be hearing a lot about today, a little bit in this talk, but primarily from my colleagues Dante and Shanglong, who will be on in this track on the stage later. You can find me on GitHub, LinkedIn. It's just first initial, last name. If you want to look me up there. There is also a Bicep community call that my team hosts once every month. It generally corresponds to when we're about to do a release. So we'll talk about like new features that we're going to release, have demos, sometimes community demos. I will put a link to the sign up for that in the chat during the Q&A. But that is another place that you can find me and other members of the team if you have questions about Bicep or ARM template deployments. Okay, so let's jump in. This talk, because it's structured as a lab, there are a few sections, and I'll try to do a graceful transition between them, but they are a little bit isolated. So I'm going to talk about like one area of features and then do a short demo and then move on to the next area. The first one, and this is sort of like a our gentle start is just types and parameterization. So a lot of you are probably familiar with Bicep and ARM syntax. Templates are a way to declare resources in groups that you can deploy. You can deploy, a single resource, a bunch of resources, and you specify what those resources are in a document. Template deployments are pretty well integrated into the Azure ecosystem. So even if you deploy something via a PowerShell commandlet or via the portal, typically there is a template being deployed behind the scenes, even if it's just creating a single resource. For more complicated things in the portal, like creating a VM that may have like a virtual network and some network configurations, that will you'll have like a multi-step flow in the portal that will create and then deploy a template. So when you do deploy a template, you are allowed to like vary the behavior of the template itself based on what are called like input parameters. These are just inputs of some type that you provide to the template, and then the template engine will interpolate them in. So easiest example you can think of is, you're deploying a template with a single storage account. You have a string parameter that's the storage account's name. So that means you can use that same template to deploy 30 different storage accounts. But beyond just letting you like vary the behavior, the engine uses parameters as a place for validation to kick in. So parameters, just by their name, the primary affordance that the template engine gives here is that parameters can be constrained. So sometimes this is very explicit. You can say, I have an integer. Oh, I have an integer, and it has a minimum value or a maximum value. You could have a string or an array with a minimum length or a maximum length. So these constraints give you a gate, essentially. The Bicep and ARM type system that I'm going to show a brief demo of, that's actually implemented in ARM as constraints. So this gives the type system some interesting characteristics that you don't necessarily see in a lot of other languages. So the primary one is that the ARM engine will always make sure that your value meets those constraints before the next step is allowed to proceed. That next step for a parameter is the deployment kicking off. For an output, it would be the deployment finalizing and giving a successful result. And for a function, it's that individual function invocation. Another feature, another consequence of types being implemented as constraints is that all types are necessarily structural because they are just checked to make sure that your value passes these constraints. So you may be familiar with structural typing from TypeScript. That means, if you have two objects with the same shape, it doesn't matter which one you say it is, they'll pass as each other. The other interesting consequence is that Bicep types are necessarily like refinement oriented. It's a very fancy way of saying that things like minimum value and minimum length are actually part of the type itself. So if you say that a string has a minimum length of 3 characters, that's considered part of the type. So Bicep will say you have a type mismatch if you try to assign a string with a maximum length of 2 characters. This is not a very common system, very common feature of type systems because all assignments are immutable. And I'm just about to jump into a demo, but the last thing that I'll say is, types can be shared with the export. So we're going to take a deeper look at that in the next section. But let's move on to a brief demo. All right. Let me know if the sizing on this window needs to be adjusted. If not, I'll take silence as just people saying everything is fine. So a very basic parameter in type would be this first line where we say we have a parameter and it's a string. You can start layering on constraints, so that same string can have a minimum length. You can declare that it's nullable, and that means that you can pass in a string or nothing at all. Any nullable parameter is optional. In addition to providing types on parameter statements, you can have standalone type declarations. So, for example, this declaration is a string that has to be one of a set of values, but it's also nullable. But types can get fairly complex depending on how strict you want to be in the checks that are being applied. So this parameter, it's an object. It has these properties which are required. Aggregates can be arrays, so like an array of strings. We also allow untyped arrays. Object props have properties, and tuples are a special kind of array where there's a fixed length and each slot within the array, each index has its own type. You can modify types to some degree with decorators. This is not necessarily something you would do all the time, but for example, objects can be sealed, which means that any additional property that's not recognized from the declaration is considered an error. And objects can be tagged as secure. Secure is something that you can only put on objects and strings. It controls runtime behavior rather than like type checking for the most part. Normally, you would say a parameter is secure when you want to make sure that the value itself is not visible to support staff or ARM engineers when you open a support ticket. Um, okay. And I did also want to mention, because this is not something you see quite as often, but outputs have the same type clause as parameter statements. So you can have anything in a parameter statement is allowable as the type of an output statement. And one other thing that I wanted to point out is when you do have two statements and you're passing a value from one to the other, you don't necessarily need to have the same type. So our constraint parameter is a string with a minimum length of 5, and we can assign that to this output that doesn't have a minimum length, because that minimum length is considered additional information. So when it disappears, it's fine. We do get an error, or a type warning if the types are not compatible. But if they are compatible, if this is a widening assignment, or if the value assigned is more constrained than the value being assigned to, then that widening assignment is allowed and it passes without any diagnostic or remark. Okay. One thing that I did want to show here before we move on to the next section is, for any type, you can use this export decorator, and that will let you reuse these types across templates. So we'll take a look at that in a second. All right, I'm going to go back to the presentation. And okay, so the next thing that I wanted to talk about is modules and code reuse. I'll kind of do the slide backwards, because the code reuse that we just saw is that export statement. So I'll have a demo with an import later, but this is the primary way for Bicep to reuse portions of templates. But by far the most common way that code is reused in Bicep is not import and export, but what are called modules. And modules let you reuse an entire template. Modules correspond to a nested deployment in ARM, and they have a template, they have inputs, and they have outputs. One important thing here is that any module template is a valid standalone template. So Bicep, when it's compiling, doesn't know if it's dealing with a module or an entry point. Every template is sort of compiled as if it could be either. You can, provide inputs, and then when the module is deployed, you can read from the outputs. So because that module is a nested deployment, that means you can treat it like a resource, so other resources can depend on it. It can depend on other resources. One thing that is a fairly recent change to Bicep is that modules can have a name, and that name is this will be easier when we look at the demo. But every statement in Bicep has a symbolic name, but modules additionally have a name property. And that name property is now optional, and in fact, its use is discouraged. The name property is used in the resource ID of the deployment, and it's really not something that you need to worry about when you are putting modules together into a larger deployment template. One other thing that I'll point out is that modules should deploy resources. Often you'll see what we would call like utility modules. Before we had like functions and imports, this was the primary way for you to share computation between templates. So if you wanted to say like, you know, to come up with a storage account name, you need a prefix and then apply the suffix and then pass it through the unique string function, something like that. Modules were the only way to like make sure that everybody was doing the same computation in the same way. But shared functions are sort of an easier way to do this. There's some gotchas when you're using modules in that way. And those gotchas, those pitfalls don't exist when you're using imports and exports. So for imports and exports, these are piecemeal code reuse. And I will imported and exported are types, variables, and functions. Everything else, everything with like a behavior in a deployment. So that would be resources, parameters, outputs. Those aren't considered exportable or importable. All right, I'll switch back over to VS Code so that we can look at a demo of a few of these things. Okay, so for our export, let's go ahead and export this standalone type. And then we have a module. And if we want to, instead of redeclaring the type, just reuse it, you can say import types.bicep and then pick up some standalone. And we're actually getting, yes, I'm at a diagnostic there because our standalone is not purely a widening assignment since standalone was nullable. Yeah. Okay. So inside of a root deployment, we can introduce a module statement. And you'll notice that because all we need for this module statement to be valid is an empty object being assigned to it. The reason is that name property is optional and discouraged. And because our only parameter is nullable, that means the parameter is effectively optional. So if we were to change that, go back here. So now, since that's no longer optional, if we were to say required properties, it will automatically include this params object and ask us for a value here. And because it has to be one of these three values, we'll say fizzbuzz. And because this module has an output, we can read it later on. So right, yeah. Because it's nullable, it may or may not be there. But yeah, we're allowed to read this output later on in the parent deployment. All right, moving along. So modules are very useful if you have an entry point that is a bicep file that's going into a different template, one or more other templates, and that can be nested at any level. But for your top level entry point, you have another option that you can use, which is a Bicep parameter file. The extension here is a little bit different. It's .bicep param, a little verbose, but it gets the point across. And this is the way that you can specifically provide inputs for your root template. The use of these files is definitely optional, because there are many ways to do this. Like I think what most people do before this is they use a JSON parameters file, or you can even use just a top level Bicep file with a single module statement. But if you do want to use Bicep param files, there are a couple of things that we can do, that Bicep can do with it, because it knows that it's looking at a definite entry point. So that would be your root deployment. So one thing that you do in a Bicep param file is you specify the template that it belongs to, and that means that when you deploy that Bicep param file with PowerShell or the Azure CLI, you only need to tell us about the parameters file, because the template it's already specified in the parameters file itself. And because that template is specified, type checking and IntelliSense in the parameters file just comes from the template's parameter declarations. The one thing that I wanted to make sure that I do a demo of is, because we know that the Bicep param file is an entry point, there's a new command that's still experimental, but I really like it, called Bicep snapshot, that works on Bicep param files. What Bicep snapshot does is it's very similar to the what if service feature, but it operates entirely offline. So Bicep snapshot will just provide a prediction of what the template will do, and that involves evaluating all of the expressions that it can, expanding all of the modules and nested deployments that it can, and then providing any warnings about where that doesn't work. All right, let me pop over to a demo of that. All right, so for our root file, you'll see we have this one parameter. It's a string. Our corresponding Bicep param file, we have to say that we're using that specific template, but that means that we get autocomplete on an IntelliSense on these parameters. So it knows what parameters are available. Can do it. Okay. So, but because we know that's an entry point, we can snapshot it. So what that did in the background was it created this root.snapshot.json file. And we only have one resource in this template, but it went ahead and expanded that to the degree that was possible. So our name, let's see, the name, passed through the unique string function. So that was executed. We know what that will look like when it gets deployed. The ID is predicted based on the amount of information that we were able to supply. So you can see that it's still an expression here, because since we just invoked snapshot without telling it anything about the environment, it doesn't know the subscription ID, the resource group name, and we can see the same thing for the resource group location. Snapshot does give you a way to provide that information. So invoking the same command, but saying the name of the resource group, the subscription ID, and then where the resource group resides, gives us a different result, because now location is no longer an expression, ID is no longer an expression, but we've patched in the subscription ID and the name. Snapshots get more impressive when you have like more complex templates that may have, a large number of nested templates, nested deployments within them. There are some cases, and you'll hear more about this from Dante and Shenglong when they're talking about what if. There are cases where what if like just is completely unable to figure out what's happening. That's called short circuiting. But you will see warnings about that in Snapshot when that does occur. All right. Moving along. Okay. One final thing that I wanted, one second to last thing that I wanted to show is configuration. Generally speaking, you don't need to configure Bicep to use it, but there are some things that are only sort of accessible via configuration. And that would let you turn on experimental features, change how registry alias resolution works. That lets you, instead of specifying domain names for ACR registries in the template itself, you can use aliases, and configuration is really the only way that you can tell us what those aliases should resolve to. The other thing that configuration lets you tweak is linter behavior. All right, let's move on to the demo for this. Okay. Um, So this is just the template we'll be working with. There is an existing storage account resource, and we're providing data back to that root template, that root.bicep template we saw before. This configuration, what this is set up to do is to turn on a linter that's off by default. This one is called the what if short circuiting linter. It lets you know when you're using a construct in your template that will cause short circuiting later on when you do a what if on that. So the way you provide configuration, it's in a file with a specific name, bicepconfig.json. So I'll turn this on by changing the name. And you can see that now when we go back to our template, we're getting a warning from this linter because we've turned it on. We've told it, tell us what's going on with warnings rather than errors or info. And it's telling us that we're using this runtime value in a place that will cause short circuiting. So if you remember that root template, we can pop back to that for a second. Our parameter is used in the name for this resource. And that means that, if we're providing something that's not known at the start of the deployment, then what if won't be able to predict like which resource it's actually affecting. The same engine that what if uses to like figure out what will happen in a deployment is also baked into that short circuiting linter. It's the same engine that powers that snapshot command. So you can have a high degree of confidence that if this linter is telling you something's going to short circuit, then it will happen when you actually do that what if. Okay. All right. Second to last switch between windows. The last area that I wanted to cover was resource decorators. These are something that you may or may not have seen before, but they are used to control the runtime behavior of resource deployments within a template. The most common one is batch size. This controls the parallelism of loops. So if you tell us that you want 10 storage accounts, by default, ARM will deploy all 10 at once, but batch size will deploy them at groups of 2. There are, however, some additional decorators that have been added recently. Prior to this year, I would say our team had a very strong philosophical stance of like, ARM is meant to work in a certain way, and if resource providers don't fit into that pattern, they should fix that. We still believe that to be the case, but we've started to introduce some decorators to help you work around resource providers that are not behaving in the way that we would ideally like them to, and for backwards compatibility reasons, can't necessarily be expected to change. Um, so the only one of these that I'm going to show that is GA is called Only If Not Exists. And this is a decorator that will tell ARM to only deploy the resource if it's not already there. So otherwise it works like an existing resource. So the backend will try to read the resource. If it's there, great, it gives you the response and doesn't execute a deployment. If it's not there, then it executes the deployment and gives you the response that was received for the deployment itself. There are a couple more that are still in the works. Wait until and retry on. I don't have a demo for these because they're not finished yet. Wait until controls how the runtime recognizes that a resource has finished provisioning, because Azure, for the most part, does not really have eventual consistency issues with resource provisioning, but there are some cases where that's not the case. You'll often see this with role assignments. Anything related to RBAC can be eventually consistent, so you might want to tell ARM to wait a bit before proceeding, just to make sure that everything has coalesced to the state that you want it to. Similarly, retry on will let you add error codes that should be considered retryable. They would normally be considered terminal, but maybe for resource X, Y, or Z, that it actually means that the resource is just not where it needs to be yet. All right, switching over to VS Code. So for the batch size decorator, like I said, if you don't specify this, all resources in this loop will be deployed at once. Normally that's fine. Sometimes you can run into like throttling or resource provider limitations. Batch size will let you work around that by preventing ARM from deploying everything in parallel. And this only if not exists decorator, you would apply this to a resource that doesn't have the existing keyword, that represents what you want the resource to look like when it's created. And just know that when this decorator is present, then this resource will act like an existing resource. So it will only perform a read and not a put when that resource is detected to exist at deployment time. This can be useful, especially for like very complex resources where you may have multiple teams working on the same one. Virtual networks are a great example of that. But it can make what if predictions a little harder to have full confidence in, because we aren't sure what will be the case. Like, will this resource exist or won't it? We don't know what's going to happen when you hit that deploy key.